All right, I'm going to start going over them because they take a little bit of time. So if you're still working, just be checking as you go. But so for number one, so I went through and I did the A, the amplitude, the B, the period, all that stuff for each of these. So for number one, A is -3. What's the negative on the front tell you? It's going to flip my sine curve upside down, okay? The amplitude is the absolute value of it. So the amplitude is 3. The B is 2 pi, which makes the period 1. So my key points are 0, 1/4, 1/2, 3/4, and 1. And then, so I plotted those on my x-axis. I plotted 3. And typically sine starts at the x-axis, goes up to 3, comes back down again. But because this is negative, it's going to start at the x-axis. It's going to go down to -3, come back up to 0, up to +3, and come back down to 1. And your sine curve looks like that. Questions on that one? Okay. Then 2, A is 2, which is your amplitude. The B is 2, which means the period being 2 pi over 2 would be pi. My key points are 0, pi over 4, pi over 2, 3 pi over 4, and pi. I plotted those. I marked the A. This is cosine. So it starts at the A, comes back down to 0, to -A, up to 0, and up to +A, which was 2. So 2 should look like that. Questions on these? Okay. Then 3 and 4 had your phase shift. So I said it last week, but I'll say it again. Next week on your test, you're most likely, it's not finalized yet, but it most likely will be 3 graphs. One that is sine or cosine. One that is tangent or cotangent. We're going to get those today. One that it is secant or cosecant that requires you to know sine or cosine. So like if you're getting cosine, then you'll do cosecant because it will require you to do sine. So in the scheme of all of that, you are going to have at least one phase shift, at least one reflection, at least one vertical shift. Like they're going to get some pieces of all this stuff. So 3, your A is 1, which means your amplitude is 1. The B is 1, which means the period is 2 pi. This time there's a phase shift to the right pi. So I would take my initial key points, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to add pi to each of these. So I get pi for the first one. This would be 3 pi over 2 for the second one. 2 pi, 5 pi over 2, and then 3 pi. And then I go to my graph. So pi is the first one, then 3 pi over 2, then 2 pi, then 5 pi over 2, and then 3 pi. And my amplitude was just 1. So and it's sine. Start at the axis, go up to 1, down, God bless you, to 0, back to -1, back up to 1. Sine curve looks like this. Question on that one. All right, then for cosine. So there's a -A here, which means, again, it's upside down. Amplitude is a +2. The B is 1. The period is 2 pi. There's a phase shift to the left pi over 2 this time, and there's a vertical shift up 1 because I added on that +2. So my key points, which start at 0, pi over 2, pi, 3 pi over 2, and 2 pi, are all going to get adjusted to the left pi over 2. So we subtract pi over 2. So I get negative pi over 2 for my first one. 0. This would be 2 pi over 2 minus pi over 2, so pi over 2. 2 pi over 2, which is pi. And this becomes 4 pi over 2, so 3 pi over 2. So on the x-axis, I've got 1 negative and the rest, well, 1 negative, 1 at 0, and then the rest positive. My amplitude is 2. It's a negative cosine. And then we have to shift it up 2. So I would always recommend that the vertical shift happen at the end, especially when you've got reflections with cosines. It becomes confusing. If you wanted to do it all in one step, you have to think, typically I start at -2 cosine, then I go to 0, up, back, down again. Well, I'd go here. Or 0, up, down again. But then I have to shift everything up 2. So I would say graph it as it normally is without your vertical shift. So I would have been at -2, 0, positive 2, 0, negative 2. This is with the reflection, but without your vertical shift. And then everything's going to get shifted up 2. So this goes up 2, up 2, up 2, up 2, up 2. And my ending curve is going to look like that, okay? Especially when we get into secant and cosecant, it's important that we understand to do the vertical shift at the end, because you're going to see, like on Wednesday, you'll see you have to find asymptotes, and to do that, we do that before the vertical shift. Questions on sine or cosine before we build on it? Because today we get into our tangent and cotangent. Okay. So 4, 6, is tangent, cotangent, secant, and cosecant. We're going to do tangent and cotangent today, and then we'll do secant and cosecant on Wednesday. Tangent and cotangent are... So here's the initial shape of tangent. It actually looks like a cubic function. It points up to the right, and it falls to the left. And tangent, unlike sine and cosine, has asymptotes. So the way we graph tangent is we're going to find our asymptotes. We're going to actually end up finding 4 asymptotes. Then we find the point directly in between them, and that's going to be our 0. We find 1/4 of the way and 3/4 of the way in between them, and that's going to be your negative a and your a. And then you're going to connect them to give one tangent curve. And we're going to duplicate this 2 more times, so you'll see it when we get all the way through, that tangent and cotangent are going to have 4 asymptotes and 3 curves. Now, why are there asymptotes on tangent? Well, think about your unit circle, right? Are there places on your circle in which tangent's undefined? Where is it? At the top and the bottom. What's the angle at the top? 90. Or in radians? Pi over 2. What's the angle at the bottom? 270. Or in radians? 3 pi over 2, okay? Or it would have also been negative pi over 2. So the way we find our asymptotes is by setting what's next to tangent, which is the bx minus c, equal to those 2 angles, negative pi over 2 and positive pi over 2. So here's what multiple periods of tangent looks like. One of the major differences is obviously the overall shape doesn't look like sine or cosine, but another difference is that tangent has a period of pi. Sine and cosine's 2 pi, tangent's pi. It happens more frequently, okay? Or it duplicates more frequently. So on the initial tangent function, you have a period of pi, which is like just one from one asymptote to the other. The domain is all real numbers except where those asymptotes exist. The range is all real numbers. This one points up and down, unlike sine and cosine. Our max is 1 and negative 1. There are vertical asymptotes at odd multiples of pi over 2. There's an x-intercept halfway between each pair of asymptotes. It's an odd function, which means it has origin symmetry. And the points that are 1/4 of the way and 3/4 of the way between your asymptotes have the negative a and positive a value, which in the parent functions negative 1 and positive 1. For sine and cosine. The very first thing we start with is the same. We find a, but it is not called an amplitude anymore. We find the period, which is now pi over b instead of 2 pi over b. And then we find our asymptotes. And the way we find our asymptotes is setting whatever's next to tangent, so inside the parentheses, that bx minus c, we set equal to negative pi over 2, and then we set it equal to positive pi over 2. And that's going to give you the middle 2 asymptotes. From the first asymptote we found, we're going to subtract the period. Now that gets us another asymptote. And from the second one we found, we're going to add the period. And now we have 4 asymptotes, which is what you need to graph tangent. So every time we graph tangent, we're going to graph 2 periods of tangent, which means we need 4. Well, we're graphing 3 periods of tangent, which means we need 4 asymptotes. Then we're going to find the point halfway between each set of asymptotes. That's the x-intercepts. We're going to eyeball the 1/4 point and the 3/4 point. That's our negative a and our positive a. And then we're going to connect the points to make the tangent curve. God bless you. All right, let's start. So it says graph the following equation, y equals tan of 2x. First thing I'm going to find is a, which is on the front of the tangent. What's the a this time? 1. Then I'm going to find b. What's b? 2, still in between the trig function and the x, so b is 2. Then I'm going to find the period, and for tangent, that is pi over b, so it's pi over 2. Then I take what's next to tangent, so this time it's 2x, and I set it equal to negative pi over 2, and I set it equal to positive pi over 2. And I'm going to solve for x. So divide both sides by 2 or multiply by a half. And I get x equals negative pi over 4 and x equals pi over 4. These are 2 of the 4 asymptotes I'm going to eventually need to get. With me so far? Then from the one on the left, I'm going to subtract the period. The period's pi over 2. So I'm going to do x equals negative pi over 4 minus pi over 2. And to the one on the right, I'm going to add the period. So I take x plus pi over 4 and I add pi over 2. So for both of these, I'm going to find my like denominator. This becomes 2 pi over 4. So x equals negative 3 pi over 4. This becomes 2 pi over 4, so x equals positive 3 pi over 4. Now I have 4 asymptotes, which is what I need to get. And if you kind of like arrange it like we just did, then left to right on here will go left to right on your axis. So the furthest one to the left would be negative 3 pi over 4. Then would come negative pi over 4. Then would come positive pi over 4. And then positive 3 pi over 4. So if you arrange it the way that we did, if you find your middle 2, from the one on the left you subtract, from the one on the right you add, then it will match it, like literally horizontally on your graph. So all these points represent your vertical asymptotes. Then we're going to find the points halfway between each of these asymptotes. So halfway between negative 3 pi over 4 and negative pi over 4 is what? What's halfway between 3/4 and 1/4?
Pi divided by negative pi over 2.
Good. Negative pi over 2. Now let's say that wasn't obvious or you didn't figure it out. Then the way you're going to find that middle point is add the 2 asymptotes together and then divide by 2. So I'd get negative 4 pi over 4 over 2, which is negative pi over 2. So if it's obvious, then you save yourself the work. If you have to find it, then you add the 2 asymptotes, divide by 2. What's midway between negative pi over 4 and positive pi over 4? 0. And what would be halfway between pi over 4 and 3 pi over 4?
Pi over 2.
Good. So those are your x-intercepts. You with me so far? Okay, then a quarter the way in, we're going to eyeball it. You don't have to find these exact points. But I'm going to mark a quarter and 3/4. So you're basically finding the halfway point between the asymptote and the 0, then the 0 and the asymptote, and then you repeat that behavior. So we're eyeballing that. We don't have to make that exact. And then I'm going to mark my A on the y-axis. My A was 1. So on the y-axis, I'm marking 1 and negative 1. And because this is a positive tangent, a quarter the way in, I would mark negative 1. And 3/4 the way in, I mark positive 1. And then I just repeat that behavior. Negative 1, positive 1, negative 1, positive 1. And then I connect the 3 dots to make my tangent curve. So for tangent and cotangent, we're going to have 4 asymptotes and 3 curves. So on the test, it's going to ask for your asymptotes. And you're going to say x equals negative 3 pi over 4. You don't have to write them each as x equals, but that's technically what they are. X equals negative pi over 4. X equals positive pi over 4. And x equals 3 pi over 4. If it had asked for the zeros, this is where it crosses the x-axis. So this is negative pi over 2, 0, and pi over 2. So start to finish on tangent. First thing you're going to do is what? A. A is 2. Then I'm going to find B. B is what? 1. And then I'm going to find the period, which is pi over B. So it's just pi. Now there is a phase shift on this, but we don't worry about like identifying the phase shift and adding it and all that stuff, because if we follow the steps that I just gave you, which is set this equal to negative pi over 2 and positive pi over 2, it will shift your curve already. You don't have to worry about shifting it later. So I'm going to take my x minus pi over 2, and I'm going to set it equal to negative pi over 2, and then I'm going to set it equal to positive pi over 2. I'm going to add pi over 2, and I get x equals 0. I'm going to add pi over 2, and I get x equals 2 pi over 2, which is pi. And those are your middle 2 asymptotes. So I already found 2 asymptotes. Okay, so then from the one on the left, I'm going to subtract the period. So I would do x equals 0 minus the period, which is pi. And to the one on the right, I'm going to add the period. So x equals pi plus pi. Which means the first asymptote, if I look from left to right, is going to be x equals negative pi. And the last one, as I look from left to right, is going to be x equals 2 pi. So now I've got all 4 asymptotes. The first one's at negative pi. The next one's at 0. The next one's at pi. The next one's at 2 pi. With me so far? Okay, now I got to find the point halfway between them. So what's halfway between negative pi and 0? Negative pi over 2. What's halfway between 0 and pi? Pi over 2. What's halfway between pi and 2 pi? In between pi and 2 pi. So that's like 1 and 2. What's halfway between 1 and 2? 1.5 or 3 pi over 2. Good. Now I'm going to mark my A, because 1/4 the way in on each of these and 3/4 the way in, I'm going to mark my negative A and A. So my A is 2, which means 1/4 the way in, I'm going to mark negative 2. And 3/4 the way in, I'm marking positive 2. Then negative 2, positive 2, negative 2, positive 2, and then connect your 3 dots. Now, what do you think is going to happen if I put a negative on the front of this tan? Good morning. What do you think would happen if I put a negative on the front? It flips it upside down. What would happen if I added something after the parentheses? After the parentheses. It's going to shift. So if I add or subtract after the parentheses, all of these zeros shift up or down. Does that make sense? I still find everything the same way. I save that till the end. I still find the halfway point by figuring out the difference between the two asymptotes. But then at the end, I would shift it up or down. So I always hold the vertical shift until the end. Questions on tangent, because now we switch. If there was a vertical shift, so if this said +1, then I would take all of the points and just shift them up 1. So my curve literally shifts up 1. I save that one till the end. Like vertical shifts, I always do at the end. Okay, so now we do cotangent. The good news is that most of cotangent is the exact same as tangent. There are 2 differences, okay? The first is the overall shape. Notice that this one, right, we flip the direction. So we push our arrows up on the left and down on the right for cotangent, which was the reverse for tangent. So first major difference between tangent and cotangent is the initial shape. The second major difference is what we set our bx minus c equal to get to our asymptotes. And that is because where tan was 0, cotangent would now be what? Undefined. So where tangent was 0, is now where cotangent is undefined, and where tangent was undefined, cotangent's now what? If my tan was undefined, what's cotangent? 0. The reciprocal of undefined, right, would be 0. So we set bx minus c equal to 0 and pi for cotangent. That and the overall shape, like we point up to the left and down on the right, those 2 things are the only differences between tangent and cotangent. So A is still where it is. The period is still pi over b. We find our 2 asymptotes. Those are the middle asymptotes. We subtract from the one on the left, the period. We add to the one on the right, the period. We find the points halfway between, just like we did with tangent. We mark that. That's our 0. We eyeball the quarter point, the 3/4 point. The difference is this time, the quarter point's going to be your A, and the 3/4 point's your negative A. And then we connect to find the cotangent, which is going to have the opposite direction as its shape. So look at example 3. What's your A? 1. What's the B? Pi over 2. So the period is pi over 2. So we change, flip. And my period is 2. Just like with everything else, you don't have to have a pi in these angles. It's still radians. So now I'm going to say bx minus c, which is what's next to cotangent, pi over 2x, equals 0 and pi, because that's where your original cotangent function is undefined. Then we divide by pi over 2. 0 divided by anything is 0. Divide by pi over 2, or change, flip, and x equals 2. These are our middle 2 asymptotes. What do I do to the one on the left? I'm going to subtract. If you add, you will get the one you already have, so you'll know you did something wrong. From the one on the left, I'm going to subtract the period. Our period this time is 2, so minus 2. And to the one on the right, I'm going to add the period. And I get x equals negative 2 and x equals 4. And those are your 4 asymptotes. So I'm going to draw the asymptotes. And I'm going to find the zeros, which are halfway between these. So what's halfway between negative 2 and 0? Negative 1. What's halfway between 0 and 2? Positive 1. What's halfway between 2 and 4? 3. These are our zeros. Then we're going to eyeball the quarter and the 3/4. And we're going to mark A on our vertical axis, which is still 1. And then because it's cotangent, we want to, at the quarter point, go up to 1. And at the 3/4 point, go down to -1. So the shape of our cotangent curve starts up on the left and falls on the right. What's the negative on the front of this causing? A reflection, which means this cotangent curve is going to take on the shape of the tangent curve. It does not mean those would be the same things. Negative cotangent does not equal tangent. The shape flips so it looks the same, but your asymptotes would not be at the same spot. So the A is going to make it flip so that instead of going up to the left and down to the right, my cotangent curve is going to flip, but my asymptotes still have to follow the rules of cotangent. So my A is -3. Which means my quarter point and my 3/4 point are going to be at 3 instead of 1. My B is still 1, which means the period is pi over B, which would be pi. I'm going to take x minus pi and set it equal to 0, and x minus pi and set it equal to pi. I get x equals pi, and x equals 2 pi. And those are your middle two asymptotes. To the one on the left, we're going to subtract the period. To the one on the right, we're going to add the period. And now I have all 4 asymptotes. 1 at 0, 1 at pi, 1 at 2 pi, and 1 at 3 pi. What's halfway between 0 and pi? What's halfway between 0 and 1? Whoa. Halfway between 0 and 1, people? Yes. So all the differences, there's a pi there, right? So 1/2 pi, or pi over 2. What's halfway between pi and 2 pi? 3 pi over 2. What's halfway between 2 pi and 3 pi? Good. Or 2.5 pi, right? Then I'm going to mark my quarter and my 3/4. And my A, I changed to be 3. 1, 2, 3, 1, 2, 3. Now, if this was positive cotangent, it would look like this. But it's not, it's negative cotangent. So I'm going to mark down here at the quarter point and up here at the 3/4 point. So that 3 is making it vertically stretched. And the negative reflected it. So this homework is again a PDF because you have to do all this work. You're not going to get a multiple choice question on these, okay? What I would recommend is between today and tomorrow, because you have tomorrow off, right? So between today and tomorrow, do the cotangent and the tangent questions. Leave the secant and the cosecant for Wednesday. If you leave it all for Wednesday, you're going to hate life on Wednesday. So at least give yourself the head start of the cotangents and the tangents.